Okay, hi, welcome to system testing. Yay, finally moving past the code. So today we're going to approach system testing, and really it's not just system testing. It's the entire test effort. So this lecture is intended to give you some hints for the second assignment, and also to raise some perhaps some questions about that. Most of when I look back on this lecture last year, I just thought that most of the lecture was just common sense. It's more or less if you are using your common sense, you will come up with what's in this lecture, more or less. There are some parts of it that might not be, but well, that is my impression of it, at least. So start with assignment 2, and in assignment 2 you should create a test plan. So and this is sort of an overview of what a test plan is. A plan is a specification on who does what and when, right? So I mean, a plan is mostly, if I think that I need to plan my day, I'm planning what I should do and at what time things should be done. Perhaps there are some deadlines or some prioritizations of my day. And if I have more than myself to plan for, I also need to say that, okay, it's not just me who should do stuff, it's you who are supposed to be here in this room today or online. Right. So, but a test plan needs to start, before we can do that plan, we need to have some kind of strategy that we're trying to follow when we plan. But really, it's a plan, it should guide the work effort, and it should make sure that testing happens. It probably contains some kind of timetable. But plans are plans, and plans are not executions of plans, right? So during actual work, stuff will happen, right? And unknown things will happen. And there will be things that we didn't plan for, as in any plan. So it will break, and so the reason often to make planning is the act of planning, and not that we should have a perfect artifact. But planning is also communication, or the actual test plan. The test plan in this case might be also an artifact that should communicate something, right? So it should focus on clarity, right? That means that someone else should be able to read this plan, understand how to execute this plan, see the common sense of doing this thing, and yeah, and perhaps also some traceability. We're going to talk about traceability later, so I'm not going to confuse you guys right now. And finally, in the plan, we also need to communicate the test results. So when we have executed the plan should tell the one who has been testing how to communicate these results and what these results are supposed to be used for. And who is going to use these results? Is it the developers? Is it management? Or is it both? Because developers need different results than management, right? Management might want to see, okay, how much money am I going to spend on testing next iteration? Should we spend more or less than we did this iteration? And a developer needs to, okay, I need to reproduce this bug, right? I need to fix this issue. So the test plan needs to communicate its result to someone. Oh, smartboard worked. Yay. Okay. So to begin, okay, we need to understand what is at stake here in order to communicate that, to build a strategy to approach that. Then we need two things, right? We need to know what is at stake. What is the goals? What is the requirements of this project? So requirements form the test strategy. So if we're going to send a spaceship with people up, we're going to have a different test strategy than if we're making the first iteration of a game, right? It's different things at stake. People versus fun for a select group of few testers, right? We need to have a budget for this. Some time, some people, some equipment. So what means do we have to execute this, to do this? If there is a imbalance between what we need to do, what is at stake, and the money or the resources that we have, then we have a problem, right? There will always be this handling. You will never have a gazillion-dollar budget and almost nothing to do. It will always be that someone else is want to use that gazillion dollars and yeah. So given these two things, then we need to come up with a strategy that sounds, yeah, like common sense. So, okay, if we have these means, what can we do? How can we approach testing in this project? What is the best way of approaching testing in this project with these resources that we have? So if we have, let's say, 100 people in our budget, maybe it would be better to focus on lots of manual testing. And perhaps we're going to do testing in pairs or stuff like that. And if we have, let's say, lots of developers or something like that, then we perhaps choose another strategy. Then we perhaps focus on automation much more. But this could also be dependent on the kind of project you're testing, right? If it's a API that we're designing, of course we're going to have some kind of automation of testing. Of course we need to have some kind of test projects that are actually trying to see if the API is useful, right? It also depends on it's not just functional requirements really, it's the non-functional requirements also. Perhaps we need to focus on making the product faster this time. So we're going to need another kind of strategy. If you're working in some kind of agile way, which I hope that you will experience, then perhaps this is not the only time we're writing a plan. So we're going to plan for each iteration, right? So last iteration, perhaps we did something. We wrote the login system for this application. For some of you, that was a year ago, something like that, right? But this iteration, we have focused on another piece, perhaps the ads that are going to show on the page, on the ad engine or something like that. So if we did that login system last time, maybe we don't need to, and we tested that fully last time, and we have not changed that. Maybe we can focus on testing on something else, right? And perhaps we're going to, if we have a lot of testing to do, maybe we want to divide this testing effort into different iterations. Maybe we like randomize our test cases and say that, okay, in this iteration, we're only testing these test cases to save resources. This test strategy probably depends on some kind of technology. Some kind of, okay, we have these servers, we have these ways of automating tests. Perhaps we have some kind of Selenium installation and we want to use that to automate the unit testing of testing of these manual test cases. Perhaps we're using unit tests. Perhaps we decided that, okay, every little piece of this code should be testable and you should use test-driven development to develop it to achieve that goal. Yeah. Okay. So, okay, now we need to to specify in the test plan what should be tested. So we have some requirements. In order to start doing this test plan, we need another artifact, right? We need some kind of requirement specification. And this requirement specification, at least hope that you've seen one of those before. You should have, right? This will specify both functional requirements. Those are the things that the system do, right? So we can log into the system. It can prevent unauthorized users from getting certain pieces of information and stuff like that. But we also have these non-functional requirements like the execution speed or the usability of the system or all the other abilities, maintainability and stuff like that. And in the first lecture, I think I talked a little bit of these static and dynamic qualities of the code. Not of the system, not only the code. I mean, a thing that we may want to test is like, is the code maintainable? Did the programmer do a good job when writing this code? Should we, in the next iteration, focus on refactoring this code since it has gone so far away from the kind of code we want to work with? So that could also be a testing, right? We need to check if the code is good. We need to do some kind of other things. So what we test needs to be specified in this plan. And I mean, it could be super wide focus. We need to test everything. If we read on Wikipedia and on test planning and stuff like that, or on system testing can be like everything. So this was one of the reasons I started this lecture with common sense. You need to think of what will give the most bang for the buck. Maybe if we realized that last time we presented this this system to the customer said, I want better usability. So this time, we want to make sure that we reach that goal. So we do usability testing, and we focus on that because we want to keep our customer happy, and we want to make sure that we get an extended contract with this customer. So then it will be usability testing. That is not even covered in this course. Right? You could like focus on usability testing in the last part of this course in assignment 3, where you're allowed to like focus on one aspect of testing that you like and dive into the research in that area. Okay. We also need to prioritize and divide the testing effort. Perhaps if this is a really small system and we have focused on automation, maybe we can retest the entire system. Maybe we can run every unit test and we do all the integration testing and we have automated all our system tests also. So, I mean, then it's just a press of a button, and of course we should do that. Perhaps every developer does that every time he changes the code. But if this is a big system, maybe we need to prioritize, and we need to think, okay, is there any part of this system that is more important than another part? Perhaps there are critical parts. I mean, if you're developing a system for a car and there is some kind of entertainment system in that car, that is not as important as the control system of the engine or the brakes or something like that. So perhaps we have different goals of the stakeholders that needs to be fulfilled with this, and we can prioritize that. Okay, every time we have rewritten a line of code in this car's system, we need to retest the brakes because that is so important. But only if we change the audio system code, then we test this audio system code. Right? Something like that. Common sense once more. So, but one of the more important aspects is what part did we implement? What did we change? And then we test that. hopefully this first assignment has given you a bit of understanding that we need to test that directly when we're programming, right? The developer should make sure that he always develops some code that is testable. And I mean, even if you don't use TDD, or even if you don't write automated unit tests, you should like test the code that you just wrote, right? And I always do that. I always make sure that I can execute that piece of code, even if it's through the entire system. Even if I run the entire system, I go into the menu and I go to the piece of code that I changed. Sort of, if it's the login system, of course I test to log in. But in the test plan, we need to make sure that we understand that the login system has been changed by Daniel. We know that Daniel is a good developer and that he's probably tested that when he did it, but perhaps someone else should also test that. And the reason for that is that Daniel might have misunderstood the requirements also, right? I might have a too developer-like focus on this requirement. Perhaps it was easy, just because it was easy in programming to do a certain way, Daniel did that way, because the code was more beautiful if I did it, right? But perhaps that is not the best way to present the login system to the user. Perhaps he should not write his password in the URL or something like that. So perhaps someone else from usability or something like that should test that part. So perhaps Daniel was testing the functional part, and someone else was testing that we actually reached the intent of these requirements, or the usability of these requirements. Yeah. Made sense? Yeah. So we should also regress. And regress was to retest things that we already tested. So if we changed a piece of code, we need to retest that code. And the reason is that it's like this. Programming is it's hard to understand the entire scope of a code, all the cases, all the scenarios of a code. So when I develop a code, I have a piece of code, some kind of requirement. I have one understanding of that requirement. And then I step away from that code and forget parts of it. And when I go back and change that code, I might not start out with the same good understanding of either the requirements or the actual code that was there. I need to rebuild some kind of internal model of this code. And perhaps I'm lazy. Perhaps I just try to implement the requirement that I get. And I cannot get the entire image of what all this code does. And perhaps it's 2 million lines of code, and I cannot even do that, right? Perhaps I cannot even read all that code and understand and build a model in my head for that code and try to understand how that code should be changed. So when we change code, we often break things. And the tests are there to make sure that we can retest, regress, and test that again. Perhaps we had parts of our system that failed the testing effort of the last iteration. So we should regress that testing also to make sure that we fix that. Or to make sure that it's still broken. Right? If we didn't focus on it, perhaps we want to make sure that it's still broken so we don't fix it the next time. If we have no way of controlling what our programmers do, maybe they will fix things. I mean, I, as a programmer, get so frustrated when I experience that my customer experience a problem that I intend to like, okay, I'm just gonna go to the toilet and then I fix it, right? And perhaps that effort was not captured in any plan for what Daniel should do. So might even be good to retest things, even if, yeah, just to make sure that we know what does not work anymore. Okay, the code components that have been updated, of course, they should be tested. This requires that we have some kind of traceability, some kind of way of knowing what should be tested, what was updated. How do we know what was updated? How do we know that just because how do we know what code was written this iteration? Or that any code was written? GitHub, yeah. So with GitHub, at least we can have some kind of comparison with the last time. And then we say, okay, all these source code files were tested. No, not tested. All these source code files were updated since last time. How do I know what manual test I should run? Sorry? It's hard to know that. If I have information like, okay, this iteration, we will focus on the login system. If I know that, and we can see in GitHub that login system code was updated, that is 2 pieces of the puzzle, right? Then we know that, okay, I need to retest the component login. There are, I mean, if you take a look at these Google videos, I at least hope I posted, they seem to have some kind of system that can track a bit that, okay, since this piece of, it's already, it's coverage information that you're using, right? So using coverage information, we can see that a certain test, we can link a certain test or a certain automated unit test at least to a certain piece of line of code. So if that line of code was updated and changed, we need to rerun that test, right? So that is one way of building this. So this traceability, and we're going to talk a little bit more about this, and I think that traceability might be something that needs more research in software development at all. We need to be better. We need to be able to like trace requirements into different source code files, into different lines of code. And we need to be able to trace the requirements out to its user interface or its CSS implementation or its HTML that was written to implement this requirement. Because sometimes a customer wants us to remove a requirement. I don't no longer want the login system or whatever. And if that login system is divided into many classes, then we're okay, I just remove the visual parts of the login system or the logical thing, or just wrote some code around it but never removed any code. Then you have a lot of dead code in your project. Rant over. So I think that is a really good topic if anyone wants to start a research career in software development. Okay, now we know what we should test. Then we have to decide how should we approach this testing. And I mean, if we have unit tests, of course we're going to run them. It might be that we don't want to. It might be that we want to write automated unit tests last instead of to the TDD way. Maybe we say that, okay, we're going to test this piece of code, and we're going to write tests for that piece of code. That is not the TDD way. That is just unit testing, right? So we can, and TDD was test first, and it was sort of a way of developing code that you practice now. But what I'm talking about now is that we may decide that we want to test this code using automated unit tests. So you need to have a clear separation in your head what TDD is and what automated unit tests are. So they are both using the same technology, and we may use automated unit tests like JUnit to write automated unit tests for pieces of code after that code was written, right? But not in TDD, right? Okay, so should we use unit tests? What kind of unit tests should we do? Should we do manual testing? Create these scenarios that we're going to talk about in 30 minutes or so. Should we do some integration tests? Should we construct this acceptance test together with the customer so that the customer knows what his gonna get and knows how to judge if he got it or not. And also decide what technologies are we gonna use. Are we gonna use some technologies for automation, like the automated unit test once more? Are we gonna do some exploratory testing? I really, really urge you to look at that video. Maybe we can have some hand raise on who has watched the video on James Bach on exploratory testing. Just. It's the video of the crazy guys who don't think that academia has any clue what testing is. It starts with that. It's a really funny video, so I really urge you to look at that. Yeah. So some of you, at least like 6 people in the class, and that was probably the best part of this course. So, so exploratory testing is where we take someone, a tester, perhaps someone like James Bach, and we put that person in front of the system, and we say that, okay, I want you to explore this system and try to find out if we're doing a good job. And we don't give them any manual tests. We don't give them any, perhaps not even the requirements, right? Because we want that person to think outside of the box. Perhaps think of the things that we tried to capture in the requirements, but perhaps did not. Like, did the user actually get his goals fulfilled from this product? Or, let's say, a couple of years ago, I bought a lot of computer games since I was sort of developing them myself, and I like to play these games. Today, I most of the time play games with either my kids or like dancing games with my wife or something like that. But I'm so amazed that that how many games there are that are fantastic products. They're so beautiful, and they have so much functionality, but they're so boring. And I sort of wish that they could have someone who was just, this game sucks, sorry. Someone who says no. I think that that would be a really good addition to many of the game studios. Perhaps it's just me. Perhaps I'm not a part of what they intended, their customer, but perhaps their customer section, whatever. But perhaps it's just that the game was really bad, really boring. So as an example, a Wii game called Boogie, dancing game. But I mean, dancing should be like stuff like that, big body movements and fun and music and stuff like that. That game had music, but it didn't have the big movements because it was better and you got more score, more points in the game if you did that thing. And no movement like this or anything with the Wii remote control. So they totally missed the entire part of dancing. Yeah. So I guess that was sort of a problem with most of the Wii games. You could bow like this and like play ping pong, like only moving your wrist and stuff like that. Okay, so is anyone awake? Did anyone agree with these statements?
We use exploratory testing.
Yeah, you use exploratory testing a lot?
The best thing is just to keep the application to the neighbor. Don't say anything and let them click around.
Yeah, so David says that he gives his application to the neighbor student and just let them click around without telling them anything.
Yes, because they will see from a different way, perspective, and they will also do the things. It's more likely I do the things I know my code can execute than doing something my way.
Yeah. So as a developer, or David is telling us that the other person has a totally different perspective when he starts up this application. He does not know anything about the code and how to successfully go through these scenarios in the code. So it's just trying to use it as an application, right? So that is sort of the a good way of trying to also understand how someone is going to use your game or application. So I was giving one of our products, one of our games, to a colleague up here, and he did not play games. So all these, the normal things like you should move your mouse and perhaps you should click the play button or something like that. Those things were missing. So you needed, and I had to write, I stood behind him and watched him trying to play the game, and I didn't want to help him because I want to capture all these problems. Because all these problems should probably, since the game was sort of directed towards his segment of gamers, should probably need to be addressed in a usability way, right? So perhaps if the player does not click the play button, maybe there should be a text guiding the mouse to that position, right? Something like that. So you can find out a lot of how good or bad you are at communicating, perhaps by just watching someone else's program. James Bach also tests other things in this exploratory testing. He tries to break the system, right? And he does evil things with the system, like, okay, I'm gonna post like a terabyte of information into this checkbox, or this, not checkbox, a text box, and then I'm just gonna see if the application fails. That is one way of, one of my favorite ways of trying to destroy student applications in post too much information into it. Yeah, and he had a lot of heuristics, different ways of trying to find problems in an application, right? But you should really, really, really look at that video. Okay, maybe we should release this to a larger set of customers. Maybe we're ready to do that. If we release something to a larger set of customers, these customers are having a better spread of experiences in maybe. And maybe we can find someone like my colleague who does not even know how to play a game, right? Because if we're only giving this to a select few people, maybe we are only preaching to require. Maybe we're not going to find the problems. So maybe we're looking for the people who will find the problems. So like Facebook, who are like, okay, we're just releasing stuff to the customers, or select few of the customers, and then we just see what happens. Does not matter, we have a gazillion customers, so let's give 1 million of them this new feature, and we see if it breaks for them. And then we just roll back, so the next time they reload a page, it's gone. So, yeah. Maybe we want to release this to the customer, yeah. Okay. Okay, but the how should also contain how we can know and understand if a result is okay or not. That means we have to decide what is okay. So if we have like, we want to make sure that we have enough unit test coverage, and we decide that enough means 85%. Something like that. So that is sort of the definition. Have we succeeded or not? So it's the same thing in usability testing. We could have like, okay, I want at least 90% of the customers to understand how to use this application without any instructions. I mean, if I had that view, maybe I could exclude my colleague who did not understand how to play, because he was not going to buy that game anyway. Perhaps he was going to buy it for his kids, and perhaps it would be a good idea to exclude that. Perhaps if I need to write instructions for him to press the play button, perhaps that is a waste of resources because it won't increase my sales. Yes, also the how. How should all these test results be presented? And perhaps how should someone else use that information? I mean, if the test results are not presented, someone cannot use them. Unless that someone who has done the testing is the same person who does the developing. So when you test your own application and you come up with some test result, then you maybe don't need to like write it down at all because, okay, I'm going to work with this. If this is such a small project, then you don't need to communicate stuff because you understand that, okay, I cannot log in. I need to fix this code. But if the testing is done by someone else and they should present to you as a developer these results, maybe you want more information. Maybe you want, okay, I need the steps to retrace or to reproduce this bug. I need to know the exact time so I can check the logs if something happened. I need other information. So a defect report could be a good idea for these kinds of larger bugs. And from the exploratory testing, I mean, if the exploratory tester just says that, yeah, I spent like 10 hours testing your application, didn't find anything, looked fine, and you pay him 10 times his hourly salary of $1,000 or something like that, would you feel happy about that? So $10,000 for nothing, you would feel. So it's also a way of presenting that we're doing a good job. It could be like, okay, we have all these test results, and we have this. We can see that in this certain component, all of the testing went okay. In this other components, 85% of the tests, no critical tests broke, and something like that. And that test result should be used to make decisions. It should guide future test effort. It should perhaps guide some developer to do some changes or bug fixes or stuff like that. It should guide someone's decision on, do we dare to release this to a public or not? Stuff like that. Can we launch the space shuttle again or not? Yes. Okay. Now we need more coffee. So let's take a break and be back in 10:05, right? 5 minutes past 10. Yes, and we're back. So we were discussing the test plan. And yeah, let's continue. So the test plan is a plan. It should guide the work effort. If you're several members of this team, maybe the test plan is a way for management to decide who does what, right? So who is responsible for executing different parts of this plan? By assigning someone who is responsible, we're also getting someone to blame, right? Might be that you're in a working community where people do not want to do work, right? And then if you're so unlucky to work in such a community, then you need to like force people to work as from management, right? The way that I would approach this is that I believe that people actually want to work if work is fun, if you get credit for what you do, and if you have fun while you're doing it, and you're a little bit able to control your work situation. So maybe that we have just one who is responsible, and then you scrum it, something like that. So you create all these post-its with different test efforts, and then you decide that, okay, I can take this one, so people can decide themselves. Right? And maybe you don't need to specify this depending on the way that the process that you're following, right? So in Scrum, all this should be on the board, right? Even if it's a digital board. And perhaps not in the test plan, and in test plans it just says that this team is responsible for this. But maybe you want to make sure that, okay, James Bach does all the exploratory testing, and he has a budget of 10 hours for that. And perhaps you even need to decide that Daniel writes the automated unit test, and David, he does the manual testing. Stuff like that. The test plan should also guide writings of tests. What requirements should be tested and what tests should be written. Like what unit tests should be written if we write them afterwards, or what manual tests should be written. So from the requirements, we're going to produce tests in a minute. I mean, the who in a plan could also be information that is vital to the other people doing this testing. So if you're, if I give you an assignment, and I give you, okay, you're going to test this product, I also need to tell you who has the information on that product so that you're able to do what you're supposed to do. Perhaps we need a customer's phone number in this, right? Who can I access to get this information? Could also be that, okay, if we're using this firm's test automation system, here is the email address or their chat that you can get help, their help system or something like that, so that you can find out information about this. Who has, beautiful English, who has vital information. And I think that it's really important to specify, I'm repeating myself a little bit, but I think it's really important to understand who should receive this test result. Because if you don't understand who should receive it, it's if you feel that your test effort is meaningless, then you won't do a good job. So if I know that Ben is going to get this, and he's going to fix the problems that I find, and he's going to be happy if I do it in a way that makes it easy for him to fix the problems, then it's much easier for me to do a good job. So I think it's a good test plan should also say that this results from this effort goes to this person or this group. Yeah. There are also always risks. So shit happens. What can affect our testing process? Maybe that we need specific resources to do this. Maybe we need a test environment. Maybe the uptime of that test environment is a problem. So yeah, and I hope that you will experience that. So I'm using a crappy web hotel, and sometimes that web hotel does not respond. So and just to exemplify that actual problem. So we need a specific server perhaps to do this testing. We need access to customers if we're going to do acceptance testing, and if they are not reachable, we cannot do it. So there are always risks, and then also a mitigation strategy. How are we going to approach these risks? How are we going to mitigate these risks? Perhaps, okay, if there is a problem of reaching the customer, if I have a phone number to that customer, it's easier to communicate and say that, okay, why are you not here? Okay, it's really cold outside. I didn't dare to go here by car today. Maybe I can test from home, or you can solve the problem, right, if you have a way of mitigating. You need access to test personnel. If it's a big company, maybe they are also working in other projects. So there's always a risk that in the other project they are getting prioritized to that project, or stuff like that, or people get sick and things like that. or their kids get sick, like me right now. Yes. But this is what I want you to focus on, and the reason that assignment 2 is done as it is. And in assignment 2, you're writing a test plan, and then you're going to give feedback to another group on that test plan. And the reason I did it that way is this. Test plan is communication. And it's really hard when you have all the information inside your head already, and then you write something that you think represents that information, and then when someone else is reading that information and don't get the same image in their head as you have, because you did not communicate clearly. It's very common for me, for example, that I give students an assignment, and the assignment seems clear to me, because I know all the other things, all the assumptions and stuff like that. But the students don't think that it's clear. I mean, we have discussed the assignment 1 quite a lot. And this is exactly this problem of communication. So communication needs to be tested. If I let my tutor instructor read the assignment, and the tutor instructor thinks that it's okay, maybe it's a bit better. If the tutor instructor says that it's, oh, you need to specify this, or you need to give them these resources, then I'm probably going to need to give them that resources. We're testing communication, right? It seems like, just from the experience of writing assignments, that there is always a group in every class who can do any assignment independent of the instructions. They do it correctly because they are on the same wavelength as me, and when I communicate, they understand, and yeah, and they just do it. And there's always a group that has trouble. Independent on how much communication I give, there's always, and the same thing will happen here, right? You're communicating, you're trying to transfer some kind of information into the head of someone else, and that communication is going to be troublesome. So if I know the person and I've communicated before, I can communicate better because I know that, for instance, some student wants more specifics, and some students don't need that. So if I know that, okay, I work with, let's say, first-year students, they need a lot of specifics, more or less guidings. Okay, first you do this, then you do this, then you click here, then you click play, and then you play the game. First, move the mouse right, move the mouse right, stuff like that. And a second-year or a third-year student, I can give them, okay, I want you to explore this area, like the assignments I give you in this course. Yes. So, I mean, in almost every type of communication, we can misunderstand each other. I mean, I write something on Facebook, and someone gets mad because I finished my sentence with a dot or something like that. And for me, it means that, okay, the sentence was finished, and for someone else, it means that I don't want to talk anymore. I write in big caps, and someone thinks I'm shouting, but really my caps button was pressed. I mean, it's really easy to misunderstand each other in emails, for instance. You probably experienced it. We're trying to interpret the email, see, is the student angry at me? How should I write it better? But I mean, if I can assume, for instance, that the test plan, I write it to myself and my group, then I know who I'm communicating with. Then I write it in one way. Maybe we have already a vocabulary that we're using. Maybe we know that we're all friends, and we have rules for communicating, and we can lift up the phone and discuss, and that is one situation. But if you're writing this to someone who is more hostile, if you have like a hostile communication with your customer or something like that, you're debating money and you're debating resources and you must fight for your resources of testing, then you're writing in another way. Then you need to motivate every little single thing. Then you need to like show traceability, how money is used in producing value, right? Okay, so in assignment 2, I want you to like, since you're gonna do both things. You're gonna try to communicate, and you're gonna read what other has communicated. And I want you to try and write as clearly as you can, and I want you to try to communicate in a good way to someone who is also in sort of the same situation as you are. Maybe you have not exactly the same prerequisite courses and stuff like that, maybe, but you should like communicate to another student. But when you're reading this, I think that you should have a little bit more critical way of viewing, and you should really do an effort in trying to help this other student in communicating better, right? I understand what you mean here, but I want you to like clarify this because it could be interpreted like this. So that is a way of helping someone else to communicate, right? So we're not trying to like break down and I don't know the English term for it, but when you take out your chainsaw and you chainsaw someone over the ankles and break down the entire frame. We're not supposed to like scream and shout and be angry at each other. You're supposed to do this. If you're doing it good, you're trying to help the other student, right?
So communicating.
You're communicating, so we're practicing this, right?
Yeah, practice communicating, giving feedback.
Yeah, feedback is hard, so we have to practice giving feedback. And actually, I've experienced the chainsaw. I mean, people have told me that I do a bad job. And I thought I was doing a good job. And it hurts. So, I mean, it's also a matter of practicing receiving feedback. So one such practice that one could do is to like, okay, I want you to criticize my work. And while you do that, I don't talk back. I only write down what you say. And I'm not allowed to talk back. So that is a really good way of just listening and try to, okay, I'm not going to talk back. I don't need to defend myself. That person is trying to help me. But it's really hard. I mean, if someone is criticizing you and say that, okay, you should not have done that, and you're doing a good job here, but you're really doing a bad job here. I don't even understand what you mean. And that is good feedback for me, because then I realize I need to rewrite this part. But I don't need to defend myself. I don't need to, oh, you're so stupid. You're just supposed to interpret it this way. So if you feel during this course that the feedback you get is of that kind, just let it go. You don't need to talk back. You don't need to defend yourself. What you're supposed to do with that feedback is to rethink and perhaps rewrite this test plan. Sounds like fun? It is. I mean, when you realize that it's not that difficult or that hard to do an error or to get feedback, it's fun to fix these problems because you're doing a better job and you're learning. Okay. The test plans should also specify what kind of results we get. So what artifact does that effort lead to? A test report, perhaps. The test report, how should it be written? To clearly communicate how we're doing, how far we have come in implementing the requirements, perhaps that everything is green or something like that. We can release this to the public, or that this area needs more focus next time. But also Who reads it? Where is it stored? Again, I'm redundant. How should we act on these results? But the last part was a really important thing. I think there should be dates. It should be on Monday, the blah blah blah. There is a deadline for doing this. So just linked to a couple of test plans, examples, and I mean, don't take this as the truth. This is from UPedu. Actually, the exact same thing as with when you're thinking of someone else's test plan. Don't take this as truth. Maybe this does not communicate back to you the way that a test plan should, right? So you don't need to follow this and do it. It could be a good idea to read this once, try to introspectively trying to understand why and why not you don't understand it, and yeah, so is it really clear? And then if you think that it's, oh, this was really great, then you implement that. If you find stuff that you don't think is really great, then you don't implement that. There's another from Rational Unified Process, or RUP. I think this one is more or less a template, and it says that different things. And there may be other things in this templates than I've presented now. And you're free to choose the things that you think should be in it, and you're free to criticize and give feedback to a student who did not include it. So it could be, in your test plan, you're missing out the test results. We have found a good way to present test results in this artifact. You can look at mine here. We think that is clear, right? That is a good way of communicating that you're missing something. I think that it's really important. Maybe you motivate why that is important. Okay. So we're going to test requirements, right? And we've talked a little bit of traceability. And this is the requirements pyramid, and I think, I don't know why I've given that link, because that was last year, so I don't remember anymore. So that information is lost to me. Maybe I need to follow that link to understand why it's given. But the testing, the requirements pyramid sort of works like this. The customer has some needs, some goals that needs to be fulfilled. We implement those needs and we fulfill the goals by implementing features. A feature is some part of the programming that is sort of cohesive. It could be a login system. It could be an ad system. It could be that in the game you're able to select different weapons. It could be more fuzzy stuff, but it's sort of a feature. So a need is fulfilled by a feature. It could be that a need is fulfilled by many features. But the need, I've written them like small clouds, because that is in the head of someone, right? Or in a group. Something more abstract. A need could be very concrete also, like I need food. The feature is implemented using two things: use cases. And if you're taking this course, you should have read a course that allowed you to learn use cases. If you did not do that, or you need to repeat it, then you should read up on the subject of writing use cases. Then you need to do that in order to succeed here. So these use cases could be that we log into the system, like a successful login or something like that. Or that we can have another use case that tells us how to log out. these features also contribute to the requirements specification, stuff that is not in the use cases. It's most often the non-functional requirements, like execution speed, or that it should be usable, or that it should be secure, stuff like that. So the login system should be secure, for instance. So it means that the same feature, the login system, could contribute to several use cases, log in and log out, and also a security feature. Each use case can have different scenarios, different ways through this. We're going to talk about that soon. And each scenario, like it's like, okay, a failed login scenario could be that in the use case of trying to log in, I enter the wrong password. And the scenario is that, okay, I enter the wrong password and should not be logged in, right? That could be realized in one or more test cases. I could have a wrong password that is wrong because it's no password. It could be a wrong password that is wrong because it's one character too long or something like that. It's the same password but one character too long. It could be that I've changed one up cap, lower caps to what is the other one? Uppercase character. It could be that I have a totally different password. It could be that whatever. So I can have many test cases. So a test case is a scenario, but with test data, specific test data. Or could also be like a way of generating that specific test data. So a single use case can have several scenarios. A scenario can have several test cases. It could also be that test cases are generated from these non-functional requirements in the requirement specification. Like, we should make sure that the system is secure. And one way of ensuring that is that looking in the database and make sure that it's not readable passwords. That could be a test case, right? We're opening the database, we're logging in, and make sure that the password saved there is not readable. It should be encrypted or something like that. So you have a use case, and you have a scenario in that use case. You can see that I've written a small path here. And this time, it's not code. It's a use case. So a scenario is sort of a path in this. So we have a use case here. Authenticate user. Main scenario starts when a user wants to authenticate. System asks for username, password, and if system should save the user credentials. User provides username and password. System authenticates the user and presents that authenticating succeeded. That is the main success scenario. If everything goes okay, that is what should happen, right? And to the right, it's what happens if you are in state 1, 2, 3, and 4. Yes. Then we have alternate scenarios, and there are two of those. And the first one is that user wants the system to keep the user credentials for easier login. Remember me, stuff like. Okay, so that is 3A. So instead of user, number 2 is that system asks for username and stuff like that, and the user does not want to write his username and password, but be remembered, so that is 3A. And 3A says that the system authenticates the user and presents that authenticating succeeded and that the user credentials was saved. That is sort of a different scenario than 4, but I merged these two states. So I've actually, on the right-hand side, simplified this a little bit. Maybe not that good in this case. The 4A alternate scenario is that user could not be authenticated. Perhaps that he did not provide the correct login information, or by that. So And that scenario can actually be reached from both free and free A. Even if the user wants to be remembered, he can still enter the wrong password. So we're ending up in 4A. And from 4A, we can see that it should, we return to step 2. So the system should present this information and ask again for username and stuff like that. So one scenario could be 1, 2, 3, 4. Another scenario could be 1, 2, 3, A, and 4. A third scenario could be 1, 2, 3, A, 4A, 2, 3, A, 4. Right? So a path through this graph is a scenario. If we want to create test cases from this, we need to specify the kind of data that is used to do this. So in the main success scenario, to create a test case for that, I need to specify a username, a password, and that I don't want the system to save. That is 3 pieces of data, right? That is what I need. That is what I input, and that becomes a test case. So scenario plus test data is a test case. So there can be many scenarios here, right? Since we have a loop, we can have as many as possible, right? We could have many steps here. Maybe we even want to, when we explore this, maybe we even want to create more states. So let's say that when we explore this requirement and we do testing of this, we realize that we want the system to act in a certain way if too many failed logins happen. If too many circles in the 1, 2, 3, 4A, 2, 3, 4A, if too many circles, perhaps 3 circles, then perhaps we introduce some kind of logging or perhaps some kind of protection system so that the user can no longer log in for a while. Maybe we introduce a new state like 5 or something like that, that happens when a user has done this more than 3 times. So, and that last part, what did I do there? By thinking of testing this system, or perhaps by testing this system, I explore the requirements. So it's not that requirements are done. They are never done. It's not that testing should be a mindless, stupid activity. It should be a mindful, clever activity. Right? You should use your brain and you should think of how to improve this system. Right? So testing is as much finding out how the system should work as it is finding out how the system is working. Oh, that was beautiful. Yeah. Okay. So now we generated a lot of scenarios. And those scenarios generated test cases. Then we need to be able to understand what requirement does work and what does not. So we need test traceability. I'm just going to see if... Yeah. So, and we never know if this works, right? Oh, it did. So sort of, all the test cases on the bottom here, we will get test results for those. So something like that. Green or red. If I have this information, I can derive which features are working and perhaps which test case are working. So sort of I want to be able to trace this back upwards, that, okay, since none of those worked, none of those worked. Since none of those worked, the feature does not work. Then I don't fulfill that need of the customer, right? So that is what I want to see, because having this test result actually means that we do not completely fulfill this use case. It's not as self-explanatory as this. It's a bit more deep, right? The test cases where we have here could be just alternate scenarios, right? It could be that those test cases never happen. Could be the case where we have stepped 300 times through the circle or something like that, and that will never happen. So we still have functionality there. So once again, this simple way of telling if the use cases and requirements are fulfilled or not needs some mind effort thinking. Yeah, mind effort thinking. So I mean, we can say to the customer that, okay, the system works, and then we just hope that he does not do the thing that we just found out by this test result. So the traceability is to verify the implementation, or no, it's not. Crap, I should not use that word. Test the implementation and make sure that which requirements do we fulfill, and did we get all the functionality that was needed this iteration? Did we focus our test effort on the correct requirements? Did we do good, so to speak? And this is really important in change management. So the other way around, if a requirement change or a need change, then I need to know which test cases should be updated or thrown away, or which new test cases do I need to write. So this traceability is both top-down and bottom-up. A way of approaching traceability is requirement coverage. So this is a test traceability matrix. It's really boring. But what it says really is that on the top we have all the requirements, and some of these requirements are use cases or connected to use cases. So use case means this, right? And here we have some technical requirement instead. And on the other axis we have test cases. So by connecting here, we can see that a single test case may test one requirement in this case, or a single test case here are actually testing two different requirements, right? We could have a single test case where we log in and then we log out, so it could cover two use cases. Yes?
Do they just test small parts of a use case, or do they need to test the entire use case to be flagged as testing use case?
So I got the question if it needs to cover the entire use case or just a small part of it. As I interpret this, it's sort of the entire, but I mean, this is again communication. So maybe it does not cover the entire use case. It's probably just, no, it's not an entire use case.
It's more back to one function.
Yeah, it's more like you have one scenario probably in that use case that is included in this one. When I come from this data with this specific test data, I've touched this use case somewhere. Yeah. Yes, you can see up here we can have some kind of stats on how many test cases do test this specific use case. In Rational, for instance, there are tools that do this for you, and I think that I've never myself tested one of those tools, but I mean, when I look at this matrix, I think that, oh, it looks so boring. So I think that you should probably have tool support for this. I'm not been sort of in a scenario where I've done this myself. So you're gonna explore it for us.
Do you know of any, like this is a test tool
Yeah.
that gives you this matrix. Do you know if there's any way of combining your test code to match this matrix?
Okay, so
In automation, like
so I get.
write your test, you can do a data annotation so that this test is connected to that use case.
Mm-hmm.
And then you can automate.
So I get automation tool question on if there are tools that automate this traceability, perhaps also down in the code, so that you write your code with a special annotation, and I don't know. That is the question. That there is the answer. So I'm not seen that kind of tools. I think probably it exists. I mean, it's not that. I mean, if we think of the test cases to the left right now, could be manual test cases or they could be automated. If they are automated, or even if they are manual, we could still like compute coverage of this. So we could have some kind of tool support that computes what kind of code was executed when you did this manual tests by instrumenting the code, just as the instrumentation works for code coverage when you're doing unit tests. So I guess we could like connect this to different type of code. I mean, annotation in your perhaps a source code comment is really easy. I mean, you can write just what kind of use case this was part of in your code also, and then you write some kind of tool that connects these things. I think that if you're interested in this may be one of the topics that you could research in your assignment 3. I have not seen such a tool. Maybe someone else has. The Rational Suite has some tools for this. Perhaps they are doing what you asked for. Here is probably the link to Rational. And it's redundant, right? Okay, so we're in the last part of this. And now it gets a bit fuzzy, because again, I'm allowing you to explore this area and have not done so much of it myself. I've said non-functional testing a couple of times, and this is where testing area and the testing techniques become really huge. I mean, all these non-functional testings could be, for example, compatibility testing. Do this component work together with the new version of the other component? Are we compatible? Yeah. Compliance testing. Are we fulfilling the rules and regulations that affect our area? Perhaps if this is a governmental system, there are rules that apply on how I'm supposed to do my work, what kind of information I'm allowed to store about you guys, for instance. And are we complying to that? So compliance testing is checking that we're complying to that or that we don't. Oh no, you're storing your information in the States. You're not allowed to do that. So if the system does that, okay, you're not compliant. Performance testing, and there are different types of performance testing. Perhaps load testing. How does the system work under load? If there are 100 clients connecting to your web server, what kind of response times do you get? Perhaps this, if we're in the case of Facebook again, where they have these a gazillion customers, this is really important. You're not perhaps allowed to write code that takes too much time, or yeah, stuff like that. Scalability testing. If we have a big load like Facebook, we need to scale up and scale down that system. We need to be able to add new servers. Does that work? Can we automatically perhaps scale up our system? What does happen if we add 5 more servers and stuff like that? Security testing, usability testing. So, I mean, many of these have specialized tools. One of those tools is Selenium. No, it's not. It's on the next slide, so we'll see them. And we can, like, in our test plan, we can go crazy and say that, or we're going to have all these abilities tested. But what it comes down to is that you had one budget also. And you had all these other things that you also need to test, your requirements and stuff like that. So we need to set realistic goals, and we need to come up with a plan. Okay, perhaps last time we did not reach the usability testing, and since we worked with usability issues this time, this is how we focus our testing effort this iteration. Yes. Load testing is more or less what we're going to check out now. Yeah, it's the Apache JMeter. So this is a tool to test a website. And it's testing the tool through HTTP protocol. Oh, it's testing the application through the HTTP protocol. So it can create different users, and they can do different stuff. We can have many threads that are testing the application at the same time. We can define how they are going to act on this web page. Perhaps they are logging in. Perhaps they are doing different things. Perhaps they're just trying to access the main page many times and stuff like that. So perhaps they are doing several HTTP requests after each other. So this is a typical tool, and it produces some test results. And this tool can be used to test a web server and a web application in a web server to see that it manages, for instance, many customers, and that we still get high throughput, and we can get the access time on average and median access time, and perhaps also the worst access time and stuff like that. And it can produce these results. Then we need to try to use these results in some way. This should guide us to some action, right? So the testing showed that perhaps that the web application was too slow, and that we did not reach our goal of having 100 customers working in this tool at the same time. So we need to focus in the next iteration on performance. Yes. So let's step back a bit. The test plan is to communicate a test strategy. The kind of test strategy depends on the goals and the resources. It's a plan. So planning is not execution. We should be prepared that the plan will not hold. It should contain some kind of timetable. It should guide our work effort and make sure that testing happens, perhaps by putting someone in responsible and giving them a due date. It should mitigate risk. It should do clear communication. It should provide traceability, and it should communicate results. It should also communicate what should be done with these results. Awesome. That was it. Questions? Sorry?
Coming time.
Their coming time. Yeah, of course they will. And I mean, Slack is a good place for this. And I'm not going to always be able to give you straight answers. I can give you my answers. I mean, if you're trying to communicate something to me, I can react on that. But I think that in order to learn this in a good way, we need to work together. Because we're a larger group, we have different abilities, different backgrounds, and we should use that as something that is good for us, right? So if you write your test plan in Swedish, maybe that cannot be executed by a lot of the other students. If you write them in an unclear way, hopefully you will learn from that. We will try to be friendly and careful, but we're going to, in a creative, in a constructive way, give each other critique in order to learn, in order to improve. Yes. Okay, so I haven't really slept much the last 2 nights, so I'm probably like gonna be a bit low on the communication side today. More or less, yes. I was at work yesterday, but it did not work so well.